you studying. All right. Dear Lord, thank you for today. Thank you for this opportunity of education. We pray for those people who are trying out for Heathdale. Please give them safety and also, sort of luck that they can get into sporting event. Thank you for the talents that you have given to them. We pray for them being able to catch up with work, that anything that they missed out as well. And we also pray for those people who are here. We pray that this lesson is going to be fruitful. We pray all these things in the name of Father, Son, and Holy Spirit. Amen. Okay. I started.
Yes.
I'm about 1/3 the way. So 20 out of 27, I think I've done like less than 10, but close to it. All right. So who is here? Who's not here? Lucas is not here. Levi not here. Sam not here. Probably sports 3. Emanuela is here. Morning. Kate is here. Morning. Lives. He was in P uniform too. Stephanie. Morning. Holly. There. Morning. Waylon is here. Morning. Samuel. Morning. Brooke is here. Good. Emma. Morning. Jack. Yes. Aston is there. Connor. Morning. Jade. Jade not here. Emily is away today. Rebecca. Morning. Jessica. Jessica not here. Bhavnita is here. Morning. Madeline. Maddie not here. Hannah not here too. Olivia. Yes. Here. Basilic is here. And Charlotte. Morning. Okay. Oops, forgot about this. Alright. Seems like a lot of people are going for tryouts, which is good. Just for those people as well, I'm recording myself. I'll put the video up on YouTube, then put it onto Canvas. That's why I've got this. Now, if you're thinking about continuing on to year 11 chemistry, or at least for bio 2, you can expect the video lectures to be always available, and that's going to be your homework. And what's used to be homework, like doing an assignment, will become your classwork. That's something for you to be aware. Okay. Now, let's try finishing off the last component of this so that we can get on to revision and then prepare you for test. Okay. So we'll do two things. The trends in the periodic table. So you've kind of touched on that using that Scootle assessment task. You okay, ladies? Yeah. Anyone? Steph? Okay. And I'll give you a worksheet on electron configuration stuff after this. Okay? So let's talk about the trends in the periodic table. So slide that we are looking at is slide 32 in this lecture note. Okay, we'll get rid of that. Okay, so the trends. Now, in the assessment tasks that you guys did with Scootle task, what sort of trends were discussed or introduced? What do you remember? You know what I'm talking about? The one that you did online and saved as PDF and submitted? Yeah, good. What trends were introduced? There are a few. Yeah? Melting points, good. Yeah. So you'd have seen or talked about how melting point changes if you go down group 2. That was one of the tasks, wasn't it? And for going across, so looking at the period number 4, there was some sort of change. Yeah. Did you write something like it went up, and after around chromium started going down? Yeah. And what you can expect is that that's going to happen periodically. So every period that you look at, you can expect very similar trend. Yeah. And do you remember how Dr. Mendeleev, I think he was a doctor, Mendeleev figured out the gallium's melting point? I'm trying to connect back to how he found out predict gallium's melting point before anyone found it. Do you remember that? Yeah? He somehow predicted, didn't he? Because he knew the pattern that happens. So potassium, calcium, scandium, yeah, melting point goes up and started going down. And if you could find a line that goes down, you can find out the melting point of gallium. That's what Mendeleev probably did. Okay, so we're going to talk about some more trends that you can find in a periodic table. Let me just fix this camera up because it's doing flickering here. That's better. Okay, next slide. So trends in the periodic table, let's start writing them. Okay, so melting point was definitely one of them. We've done a Scudo activity. Sorry about the animation there. So trends, that is something that you can observe, something predictable pattern, okay, that you can find. And Mendeleev's gallium's melting points, that's something that I mentioned already. That's Mendeleev there. All right. So other trends that we can observe in. So trends that can be observed. Reactivity. Oh, let's add melting boiling points as well. Now, I already introduced one reactivity trend for group 1 metals. The Brainiac video, Richard Hammond. Hope the visual is coming back. What sort of trend did you observe again in the video? Yeah. Reaction with water, and what happens if you go down? Good. So as you go down a group 4 metals, okay, 4 metals, reactivity went up. Yeah. Reactivity increased as you go down. Do you know what I'm talking about? Maybe you are white, I don't know. There's a video that we watched before. There might be another link that I can remind you about as well. We'll talk about what's called atomic radius, right? Radii. Okay. What do we mean by radius or radii? You might use the word in math when you look at area of circles. What do we mean by radius? You should have done this in math. Radius, what do we mean by that? How do you find the circle's area? Yeah?
By measuring from the inside to the edge. No, like from the middle, I mean, to the
Good.
edge.
Yeah. So inside, yes, we are looking at center. Yeah? Center to the edge, the perimeter of the circle. Yeah? So center to perimeter, that's a distance called the radius. Yeah? Atomic radius. And radius really just refer to circle, There's a dot, distance between that and that. Yeah, center to the edge. So there's a pattern for it too. Oh, it does say physical properties. Now, that is referring to melting and boiling points, partially. We can also talk about solubility, miscibility, so whether it dissolves into water or another type of solvent. Okay, so physical property refers to melting boiling points as well as solubility. I'm pretty sure you have a bit of space after that, so solubility. Add that after that. Yeah, they're all considered to be physical properties, something that all atoms have. Okay, so they are the observable trends that we'll be talking about. And I hope you already figured out. You can talk about across a period and down a group, there will be different trends. And I should say metals and non-metals will be separately figured out. What was the title again? Trends can occur. There. So across a period, so horizontally that way, or down. Across a period, down a group. And what did I say? We have to look at metals and non-metals separately. So metals and non-metals separately, because they have got different sort of trends if you go across or down separately. Okay. Now, one thing I'm already showing there on that slide is that, well, figure 3.6, that's saying relative size of atom and selected main group elements, the atomic radius, so the size of atoms, just changes. Okay, and the unit is in a picometer, 10 to the power negative 12. So it's very small, isn't it? So what do you see in terms of size if you go across a period? If you go across a period, what are you seeing? For metals, do you see where the metals are? So if you look at on the mouse, lithium to beryllium, they are metals, aren't they? If you go to the right, what are you seeing? Increase or decrease? Decrease is good. Sodium to magnesium? Decreasing. Potassium to calcium? Decreasing. So what can you say about metals' atomic radius? As you go to the right, atomic radius decreases. Okay. How about non-metals here? Let's look at the numbers here. So BCNOF, if you go to the right, the atomic radius decreases. Yeah. Atomic radius from aluminium, oh, that's a metal, by the way. Silicon to PSCl, what are you seeing here? Decreasing. Okay. So that's a trend. Okay. As you go left to right, atomic radius decrease. That's already a conclusion that you can draw from this diagram here. There are some, like this one here, 140, 141, 143. There are some exceptions, but generally speaking, from left to right, atomic radius, if you go to the right, it becomes smaller and smaller. So atomic radius decrease, yeah? How about down a group? What are you saying here? Visually, lithium to cesium, what's happening in group 1? Decrease or increase? Increase. Good. Yeah, that. What's happening to the group 2? Yeah? So 113, 160. Oh, it decreased a bit, but 215, 217. Generally speaking, it's increasing, isn't it? Yeah? So they're the trends that I would like you to be able to figure out. Where's my mouse? There you go. Okay. Now, reactivity of metal. You already answered to this question, and because Emanuela wasn't really sure what I was talking about, I might just quickly show the gist of it. And I'll pause this video if the internet is working. Did I mute it? I think I did.
You may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate.
What happened from lithium to potassium so far? It's responding a bit slowly. So lithium, Richard put that into water. Wasn't much of a reaction. Yeah. Sodium, hope you saw a little flame coming out. Yeah, it caught on fire while it was, trying to react with water. And the potassium, it had a bit bigger. So as you go down, what are you seeing for group 1 metals? Becomes more and more reactive. And that trend will continue. Okay. Let's go with that. Okay. Now, in chemistry, being able to explain why is equally important as memorizing some facts. Okay. Memorizing facts like, as you go down a group, metals become more reactive. That's a fact. And we can't argue with that, okay? Because you can do the same experiment again, you will always get the same result, yeah? Why does it happen? That's something you need to be able to explain, all right? So, reactive metals. Let's use the word U. So as you go down group 1 or 2, what's going to happen? The reactivity increases, as you saw in the video, all right? Let's think about why. Hint is that the distance that's between the valence shell electron and the nucleus. Okay? Why do you think that it increases? Yeah, Jairus?
I don't know if I'm getting, but is it because it's got more room to move, which means it can move faster?
You could guess that way. Yeah. Not so much of movement to the inside. It's more to do with atomic radius. I'm already using the word here. All right. Good guess though. Yeah? Yes, it gets bigger. That's going to be your first line. Let's use that. So, here's the reason why. Okay, so first line that explains the reason why this happens is that as you go down, atomic radius, good. increase, increases. And what does it tell you? And how do you connect that to the reactivity? So when atomic radius becomes longer and longer, what happens to the interaction between something that's positive, nucleus, and the electrons? See, if I had same number of proton, lithium, okay, and if you just being an electron, I might be able to still pull you fairly well, right? But Charlotte at the back, if I was cesium, even though I have 55 protons in me, I might not be able to hold on to you that easily. Does that make sense? So you might go wander off and react with water. Yeah. Whereas Jerus, I still have hold on you. Yeah. So you might not be able to react as well. Does that make sense, guys? Yeah. So let's continue. So as you go down the group, atomic radius increases, meaning what? This means, can you finish the sentence, anyone? Yeah? That'll be the final line. I want one more line in between that. Something that I was talking about between the hole that I have. Jerris,
that means the atom can hold more electrons?
He'll hold more electrons, sounds like number of electrons.
Like more space. So is that what you're trying to say?
What you sound like is the number of electrons. So let's talk about the pull that protons have, the nucleus have. Can someone try finish the sentence? So atomic radius increases, therefore, what? The hold that I was talking about. What sort of pull? Shall have a go? So think of this metaphor. Me, lithium, only have 3, but have stronger pull towards electron to Jerus electron here, okay? Because we are so close, okay? I can still attract him. Because I'm positive, he's negative, okay? But if I was cesium, even though I have 55 protons, a lot more protons, I'm still very positive. But because there's so many shells in between, I can't hold on to the electron sitting far at the back. Imagine you are being in a concert. I don't know, my wife is going to, what's his name? Not Ed Sheeran, the other one that's coming. Bruno Mars, yes, thank you. I bought a ticket for her Valentine and for birthday gift. Anyway, so she's going to Bruno Mars. Now, imagine that you are like right at the front, like 5 meters away from Bruno Mars. And if you're a big fan, you don't want to leave there, would you? Yeah, because the distance is so close, you can even almost touch. You may not be able to, but you want to touch, and you don't want to leave there, right? But people like my wife, who already gave birth to 3 kids and don't want to stand up for 2 hours, she would rather sit at the back and still enjoy. Okay? But there's a freedom for her to leave, maybe go to the toilet or go something to eat while the show is happening. Okay? Now, if there was a distance, more distance from the center which attracts you, right, you might be able to leave. Okay, that's what happens. That's the difference between lithium and cesium. Does the metaphor make sense to you? Yeah? You were going to say something? Yeah? Okay. So if there was an increase in atomic radius, that means what? Can anybody finish the sentence now? The final line will definitely be reactivity increases. So distance becomes more then.
So what you're saying is like it's like when you got 2 magnets and the closer you put them together, the more strongly they connect to each other.
Exactly, that's what it is.
So if the
You're getting there. They opposite attraction between the opposite charges. Yeah. What happens? So the distance is becoming more and more as you go down. Attraction is becoming, yep, attraction between opposite charges decreases. Now, it's much easier for you to put a magnet away if they're not close, are they?
Oh, okay.
Yeah? Like my wife sitting at the back, she might be able to go to the toilet more often than people at the front. Yeah? So hopefully one of these metaphors making sense. Sorry, that's not really clear, was it? My red is dying. So it says decreases, yeah? And we can finalize the sentence here. Therefore, the reactivity increases. Okay? So preparation for you, expect a question like this. Something that you have to explain why things occur for any trend. In this case, it was metals reactivity. Okay? Think logically. Hopefully, you can come up with some metaphor in your head that makes sense. Reactivity increases for metals because as you go down, atomic radius increases. And that means attraction between opposite charges decreases. Okay? Hope that's logical there. And I'm expecting, again, you to be able to write 3-sentence paragraphs for 3 marks question. Okay? All right, let's move on to some other trends. I was going to do this prac, but I thought that people will be aware, so didn't prepare for it. Now, I will do this activity by giving you the worksheet, which will be to do with this. So what I would like you to do is to leave next 2 pages. What I'm saying is, if you have got the notebook, all right, don't start using one side of the book, because what I will ask you to do is to glue in a worksheet over 2 pages. Okay? So leave 1 page gap, because I want you to paste periodic table in the middle of 2 pages. Yeah? So you can write things around it. Okay? I'll give you the worksheet in a minute. And I'll start talking.